A standard naming system has been designed for the naming of complex carbon compounds. For example, the straight chains can become more complex if a hydrogen is replaced by a side chain. We can take a chain such as hexane and join a propane onto the second or third carbon atom. The longest chain is found. If the propane joins onto the second carbon atom, there are 8 carbons and the longest chain is octane. The branch chain is 1 carbon long and is methane, less a hydrogen. An alkane that joins onto another chain is known as an alkyl group, in this case, methyl. So the compound is named 4-methyloctane. If the propane joins at the third carbon, the longest chain has 7 carbons and is heptane. The branch chain is ethane less a hydrogen. This is known as the ethyl group. So the compound is 4-ethyl heptane. There could be lots of branches. We could have a 6-carbon chain with 2 methyls, an ethyl, and another methyl attached. It will be named 4-ethyl 2,2,5-trimethylhexane. A mouthful, but all quite logical. The side chains are in alphabetical order, so the compound cannot be named in different ways. Although we draw the structure flat, the molecule will be all tangled up, roughly as a ball. In hydrocarbons, a halogen atom can replace a hydrogen simply, in a process called a substitution reaction. Methane reacts with chlorine in the presence of ultraviolet light to form chloromethane and hydrogen chloride. Subsequent substitutions by the halogen form dichloromethane, then trichloromethane, which is also known as chloroform, a powerful anesthetic. And finally, tetrachloromethane, more commonly known as carbon tetrachloride, used as a solvent. Here we have a hydrocarbon that has reacted with various halogens. The naming is once again very simple and obvious. The longest chain is named, in this case pentane with 5 carbons, and then the halogen. The naming would go something like this. Start with the pentane chain, and we name them in alphabetical order. 1, 2, 3, tribromo, 4, chloro, 1, 1, we say the 1 twice, so it's 1, 1, 2, trifluoro, 3, 4, diiodopentane. If the last hydrogen was replaced with an OH, it would not be pentane, but pentanol. We would then have to renumber everything, because the carbon with the OH on it becomes C1, from which the compound is numbered. And if it was a COOH group at the end, it would be hexanoic acid.